Welcome to the Unit 4 test review. Today we'll go over the Unit 4 test results that you took on Illuminate. So this is Math 8, Unit 4 District Assessment Test Review. Your test answer results are on Illuminate. So if you could go through Clever, go to Illuminate, click on the Unit 4 District Assessment, and you will find your answers as you review them. Your test corrections, you're going to use the error notebook template. They're available in class or in previous Google Classrooms. You'll see these. And you'll also see the link to the video on Google Classroom. The test and quiz error notebook template looks like this. It has your name, assessment, date, period. The important points are here that you will write the problem number, rewrite the problem as you answered it with the error. The whole goal here is to identify your error. And so another goal is that if you're not answering the questions, can you please start to build the skill to create and identify a strategy that you can use in the future, a test-taking strategy, so that you can answer them more accurately. And then in this other column, this third column right here, you are going to do the correction based on the video and what you've learned. And as you're going to correct and check, you're going to solve the problem correctly, checking your answer, and you will have to do it completely. If there's drawings and diagrams and steps, you need to include all those things. Okay, problem 1. Question 1. Consider the expression 1 over n to the 6th. Select all expressions that are equivalent to the expression above. Well, some of the early things that we could quickly notice, if this n to the 6th, which is in the denominator, we know that if we could be moving it to the numerator as n to the negative 6. 1 over n to the 6 is equivalent to that. And then any combination thereof. So let's look at our 4 answers and let's see which ones they came that are equivalent. If we look at example A, we have a power to a power. So the rule says when you take a power to a power, you multiply -2 times 3, which is equal to n to the -6. Notice it does not match the one that was given here. However, they do want you to know the rule at the top. So you have to take it, it's really a two-step thinking. Look how tricky B is here. Look where the negative sign is. So in this case, why is this not true? N to the -6 is not equal to the same, it's not the same as negative n to the 6. This means 1 over n to the 6, the one on the left. The one on the right is n to the 6, and then whatever answer you're going to get, you're going to turn it negative. Totally not the same. Here, we're going to, when the bases are the same, the rule says let's add the exponents, -3 plus 2. Well, when I add those together, I get n to the -1, or 1 over n to the 1st. That's definitely not the same. So let's apply the rule to D. -9 plus 3. If you have access to a calculator, you can plug in -9 plus 3 to get n to the -6. Again, another really tricky thing here, because you're given 1 over n to the 6, but knowing that you have to change it to n to the -6. Problem 2. Question 2. Simplify the following expression. Okay, well, we have probably one of the easier questions on the test. The bases are all 2, and you're multiplying. So what do we do with the exponents? You're going to add the exponents under the rule, where we have 2, and now we're going to add all the exponents together. 3 plus 2 plus 0, and that's 2 to the 5th. This number is small enough that you can do 2 times 2 times 2 times 2 times 2, and I believe it's 32. So either of those two answers will be correct, and here we go. So again, the test is really testing your knowledge. Can you find the answer in the first case, but can you take it even further and find the answer all the way out to 32? Problem 3, question 3. Which expression is equivalent to 2 to the negative 2 times 3 to the 4th? In this case, it's a little tricky. These bases are not the same. One base is 2, and one base is 3. So in this case, what do we know about 2 to the negative 2? We know that 2 to the negative 2 can be written as 1 over 2 squared, or 1 over 2 times 1 over 2. And we know that 3 to the 4th is equal to 3 times 3 times 3 times 3. So we're looking at something that is 1/2 times 1/2 times 3 times 3 times 3 times 3. And that was answer B on the test. The other, it could become a little bit tricky. I could see where you might get a little confused because this has a negative sign and that has a negative sign. It's something that is easy to confuse in exponent rules. Be aware that a base number to a negative power is not a negative 2, it's a 1/2, because it drives it into the denominator. Question 4. Which expression is equivalent to 10 to the 4th times 10? Oh boy. Every time I see a number without an exponent in an exponent problem, I'm going to put a number 1 right there. It's become a very apparent problem that we are, as a whole, in all the classes, failing to recognize that there is 1 10 there. So let's put a 1 there to keep its place. And now we can evaluate. The 10 to the 10th is in the denominator. These are all in the numerator. So the ones in the numerator, let's deal with those first. 10 to the 4th, they're multiplying, so we're going to add all the exponents together. Let's just keep the thing in the denominator for now, make it 2 steps. And now we can go 10, I'm going to add these up. That's 4 plus 1 is 5 plus 2 is 7 over 10 to the 10th. At this point, you could expand it out and cancel 10s, or you can apply the rule a second time. If I'm dividing, I'm going to subtract. And I end up with 10. 7 minus 10 is negative 3. Or I might have an answer where it says 1 over 10 cubed. Let's see which of these two is the right answer. Okay, 10 to the negative 3. C was the correct answer. Now, when you go back and you do your air notebooks, you can't just write the letter C. You're going to have to do all of this writing. Question 5. Which decimal appears to be a rational number? Okay, so on this, I would refer back to the handout that was given. There was a handout that was given that had rational and irrational numbers. And in that diagram, the rational numbers were broken up in a Venn diagram where we had natural numbers, whole numbers that included 0, integers, and then we had fractions, and we had terminating decimals like 0.45. We had percents, 87%. Things that were terminal, things that terminated, like 0.83 repeating. And then we had irrational, and under the irrational, pi was there. And other things like square root of 3 were there. And then non-terminating numbers like 2.4716, and then we put a bunch of dots there because they're non-terminating. So if you look at, some of these have patterns. And it says, which of these is a rational number? Well, if I look at this pattern, I can see 1, 4, 2, 8, 5, 7. Then it repeats again, and then it starts repeating again. So this is the only one that has a pattern. So that is why A is the rational number. Question 6. The value of pi cannot be written as a ratio of two integers. Which statement then is true? Okay, well, we know that when you can write a number as a ratio, then it is rational. A ratio is a number A over B. Pi cannot be written, does not equal some ratio A over B. So that means it cannot be rational. Let's see what the answers are. Pi is a rational number. Well, that doesn't make any sense. We already know it's in the column for irrational numbers. B, the decimal expansion of pi repeats. Doesn't. That would mean it was a rational number. The decimal expansion of pi terminates. We know that would also include being a rational number. So these three things are all part of the definition of rational. So only one answer made sense, and it was C. Question 7. In Tom's calculator, a number that can't be displayed in 10 or fewer digits is represented by a scientific notation. So what does that mean? It means that his calculator, if the number is bigger than 10 digits, it shows the answer as scientific notation. So he enters this number in a multiplication problem. The answer is 7 times 10 to the 11th. We know, is that going to be a large number or a small number? Where the exponent is 11. That means there's going to be 11 zeros, and it's very large. So let's look here. Here's the calculator. And here we go. Let's count how many zeros here for the correct answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See where the decimal point is here? 7. Decimal point, and then you're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you're going to use zeros to keep. And then you can add your commas. The answer was 700 million. Question 8. What is 0.0000025 expressed in scientific notation? Well, we know this is a very small number. The exponent's going to be negative. Let's count how many times we're going to need to move this. 1, 2, 3, 4, 5, 6, 7. So we're going to move it 7 times, but we're making it smaller by 7 place values. So we're going to need to move the decimal point here. The first number is, of course, between 1 and 10. And then we moved it 7 places to the right. We made this number much, much bigger. So you compensate by making it much, taking away 7 tens. Question 9, almost to the end here. The radius of a typical golf ball is approximately 2 times 10 to the negative 2 meters. In contrast, the radius of the sun is approximately 7 times 10 to the 8th meters. How many times larger is the sun than a golf ball? Now, this is important because they're relating the sun to the golf ball. So the sun we know is 7 times 10 to the 8th. And then you're comparing them as a ratio. So it's 2 times 10 to the negative 2. Well, the coefficient 7 over 2. And then we have times 10. The rule says that if our bases are the same, the exponents we can subtract. So we have 8 minus negative 2. At this point, we'll pause for a second. There's a song for two negatives that subtract. The rule is if you subtract a negative number, it's the same as adding that number. So we end up with 7 divided by 2 is 3.5 times 10. And then we have 8 plus 2 is 10. It's already in scientific notation because the lead number, is it between 1 and 10? It is, so it doesn't need to be moved another time. So that's really convenient. We end up with the 3.5 in box 1. And then 10 times 10 to the 10th goes in box 2. Final question. Question 10, the best question on the test. His name's Jerry, entered the number 50 million on his calculator. Then he pressed X squared key to square the 50 million. What is the result in scientific notation of squaring 50 million? And how did you find your answer? I love this question. It's great because a lot of people got it correct to put this as 5 times 10 to the 7th. Now you're squaring it. So the easiest way to do this is to do it. There's several ways you can do it. 5 times 10 to the 7th squared. It's a power of a power of a product. So each factor gets squared. You get 5 squared times 10 to the 7th squared. 5 squared is 25. And then power to a power, we multiply. So 7 times 2 is 14. You're almost there. You just need to move it 2.5. You've got to get the leading number between 1 and 10. I made it smaller by 10, so I'm going to make this 10 larger by 1, 10. Change that to 10 to the 15th. And now all I have to do is explain my process. So 1, I wrote 50 million in scientific notation. 2, I squared, and I used power of a product. And then 3, I rewrote in scientific notation. That was it. That concludes our test. Let's take a look at question 10 as a quick example to finish up. What would this look like if you messed it up? All the way back on the example. Let's say, for example, I was doing problem number 10. And I would rewrite the problem exactly as you saw it. I would write, and it says 50 million is squared, and I continue writing the entire problem down. I've done dots to be brief, but you cannot. You need to write it down completely. And now I do the correction in the check, and I do it just the way I did it on the other page. So I would say, okay, well, I have 50 million, and I'm going to do x squared on the calculator. And then let's say my mistake was I did 50 million. A common mistake was I times 2 and I got 100 million. That was a common mistake that was made. Squaring is not the same as timesing by 2. And I'm going to identify my error there. And my error is that squaring is not the same as times 2. Here I do it the right way. I would do 50 million x squared. I do 5 times 10 to the 7th squared, 5 squared times 10 to the 7th squared is 25 times 10 to the 14th, which is 2.5 times 10 to the 15th, and then I would do my explanation, which was the second point. My explanation, was 1, number 1, number 2, number 3, as we looked at just previously. Good luck. Remember that the important thing is, if you didn't do the explanation part here on the test corrections, you'd only get the half point. It's only worth half credit for corrections, so you could get an entire point if you do both this and this, because the question was worth 2, but you can get half the credit. Good luck. I hope that you turn in your test corrections. It's the most important way to get a good increase in your grade.